Right now, this game is making millions of decisions a second, painting millions of pixels, and there's nothing plugged into it. No internet, no signal, nothing feeding it from the outside, which is strange when you actually stop and think about it. If nothing's coming in, then where is all of this coming from? You probably think you downloaded one big program. You didn't. Almost all of what came down was pictures and sound and worlds to walk around in. The part that actually thinks it's tiny. On a 100 GB game, the real instructions might be a thin little sliver of that. So when your finger taps the screen, what actually wakes up? And where was it hiding before you touched it? Now, most people quietly assume the internet is doing the real work, that a download is just streaming that finished. It's a fair guess. It's also exactly backwards. There is a kind of gaming that lives and dies by the internet. It's called cloud gaming, and it runs the other way around. Some machine far away plays the game for you and just ships back a video of it. Lose your connection and it's gone. But your offline game? It quietly copied a whole computer's worth of work onto your device. So let's go find it. This is where your game sleeps when everything's off, and every single one, every single zero is a little pocket of electrons trapped on a gate too small to see. Just sitting there, holding perfectly still with no power at all. Here's the part almost nobody knows. That charge slowly leaks away. The bits start to rot. So even while your game does absolutely nothing, the drive is quietly reading it, checking it, patching it back up. Your save file is being repaired while you sleep, but none of this can think. Something still has to reach in and wake it up. So you tap, and for a beat, it looks like nothing's happening, but something brand new just came alive in there. Your operating system, the quiet thing running the whole show, hands the game a fresh identity and a private little world of its own. Engineers call that a process. And here's the clever bit. It refuses to wait around for the whole game to load. Instead, it grabs a map of where everything is and just starts pulling pieces in the moment it needs them. The game's already running before most of it has even shown up. But to pull that off, your device has to tell a really convincing lie. A lie about memory itself. Here's the lie. Every program on your device is convinced it owns a huge, clean stretch of memory all to itself. It doesn't. Behind the curtain, a translator is quietly scattering those neat little addresses across whatever real memory happens to be free. And when the game reaches for something that isn't there yet, the whole system darts off to storage, grabs that exact piece, and slips it into place. So fast, the game never feels it. That's what a loading screen usually is, by the way. The game hoarding things early, so it never has to stop and gasp for air later. But strip all of it down, and you're left with numbers. So, who reads the numbers? And how did they even become numbers? A person wrote this game in words, real, readable, almost English words, but a processor can't read a single one of them. So long before it ever reached you, all of it got ground down into raw binary. That's the only thing the silicon actually understands. And here's a twist that even a lot of engineers forget. On modern chips, those instructions get translated again right as they run. The chip quietly chops the big, messy ones into smaller, simpler pieces behind the scenes. What we call the processor's language is really just a mask, a familiar face on a much weirder machine underneath. But not every game gets ground all the way down before it ships. Some of them bring a translator along for the ride. and that one choice. It's a quiet little war over speed. There are two ways to think about this. The first says, grind everything down to raw machine code before it ships. Then it runs the instant you hit play. No warm-up, no waiting. The second says, send it half finished and finish the job live while the game is running, which sounds slower, sounds kind of insane, honestly. But here's the twist. A translator that gets to watch the game actually play can outsmart one that guessed ahead of time. It sees which paths get worn down the most and leans into them. The cost. Now and then it has to stop and tidy up after itself, and you feel it. A tiny hitch right in the middle of the action. There's no winner here, just a trade. Either way, it all funnels down into the one machine that actually does what it's told. So here it is, the thing everything's been building toward. And after all that, it's almost funny how simple it turns out to be. Grab an instruction, work out what it means, do it, jot down the answer, then go again. Billions of times a second. And the instructions themselves are almost laughably small. Move a number, add two of them, compare them, jump somewhere else. That's basically the whole language. Every world you've ever gotten lost in is built out of those few little moves. But there's a catch buried in here. Because every time it reaches for the next scrap of data, that scrap turns out to be absurdly far away. This is the quiet embarrassment of every fast processor. It spends a shocking amount of its life just waiting. Reaching all the way out to main memory is painfully slow. The core can sit there for hundreds of cycles, twiddling its thumbs, waiting on one lousy number. So engineers solved it the way you'd solve a messy kitchen. Keep the stuff you grab most often right at your elbow. Little pockets of blazing fast memory tucked right up against the core. They call it cache, and it flips everything on its head. Because now the fastest game code isn't the one doing the least work. It's the one that keeps its data close and neat. But even that doesn't fully cut it. So to buy a little more speed, the chip starts doing something that really shouldn't work. It starts guessing. Picture the core sprinting along and it hits a fork. Left or right? The safe move is to stop and find out. But stopping is the one thing it can't afford, so it just picks one. It commits and charges down a road it isn't even sure it's supposed to take. Guess right, and the work's already done. Free speed. Guess wrong, and it quietly tosses everything out and backs up like nothing happened. It's why the very same code can crawl on shuffled data and fly on sorted data. Nothing changed except how easy it was to guess. And here's the uneasy part. A few years back, people realized all that guessing leaves faint little smudges behind. Smudges you could read to pull out secrets the chip was never supposed to hand over. But all of this cleverness has to rest on something real. So let's keep going down. This is the floor. It's a switch. That's honestly it. A tiny electrical switch, so small you could pack billions of them onto something the size of a fingernail. Nudge a little voltage in, and current flows. That's a 1. Take it away, and it stops. That's a 0. Wire 2 of them together, and suddenly they can make a decision. Wire up a handful, and they can add. Stack those up. And you've got the part of the chip that does all the math. There's nothing hiding under this. No secret ingredient. Just electricity moving through switches in perfect time. Billions of times a second. That's what a thought looks like inside a machine. But this same river of electricity does one more thing. It turns into a picture. And oddly enough, the processor barely lifts a finger for that part. The core we've been following is sharp, but really, it's just one very clever worker. And one worker, no matter how clever, can't paint 2 million pixels in time, so it doesn't even try. It scribbles out a stack of orders and hands them off to a totally different chip. One that isn't clever at all, not on its own, but it's got thousands of tiny workers all doing the same simple job in the same instant. One little program running on every pixel at once. That's how a whole frame appears in a sliver of a blink. And here's a secret from inside the business. Almost none of that lighting is real. The soft shadows, the glow, the way light seems to spill across a room, most of it is a gorgeous fake. Clever tricks that just happen to look right. So now you can see the world, but you can hear it too and feel it. Sound is just numbers as well, a staircase of them, thousands every second, tracing out the shape of a wave. A little converter smooths that staircase into a flowing signal and shoves a speaker back and forth to push the air. Numbers, turning into something you can actually feel in your chest. And here's the odd thing. Sound is fussier than video. Drop a frame, and you get a tiny stutter you might not even catch. Drop a scrap of audio, and you get an ugly pop that everyone hears. So sound gets to skip the line, and your touch? Your finger isn't really pressing anything. It's nudging a tiny electrical charge on the glass. That's why the screen goes deaf through a glove or panics when it's wet. It was never feeling pressure. It was feeling electricity, sight, sound, touch, 3 separate rivers. So what ties them into one living world? It's a loop, one relentless wheel, turning dozens of times a second. Check what you did, move the world forward, sort out the physics, paint the frame, show it, then start over before you can even blink. And underneath that one wheel, everything we've chased is happening at the same time. The core thinking, the graphics chip painting, sound pouring out, storage quietly feeding in the next slice of the world, and look what's still true. That cable never got plugged in. It never had to, because every last piece of this is happening right here, in your hand on your own silicon. The internet was never doing the thinking. It only ever carried the extras. Updates, other players, a license check. Never the world itself. So the next time you're out somewhere with no bars and you open a game and a whole world just blinks into being, you'll know what really happened. Nothing came down from the cloud. Nothing streamed in. That world got built right there in your hand, out of trapped electrons and tiny switches snapping on and off billions of times a second in an order so precise it talks your eyes into seeing a place that was never really there. It was all inside the whole time. You just couldn't see it. Stay curious. Stay curious, a woman.